voice, and let's talk about enthalpy change of combustion, the reverse of enthalpy change of formation. We need to take note the average band dissociation energies. Okay guys, you need to familiarize the different types of chemical reactions because sometimes it will never mention the chemical reaction or the chemical formulas in the problems in the future. Okay, sometimes worded problems and statements, no, they don't break it into chemical formula. So that's the difficult thing. Okay? Then you have to familiarize how it is being done, like that, blah, blah, blah. What are the formulas? So you can balance the chemical equation, you can have your correction, and you can manipulate things better to solve what is being required. Okay? Now we have here, okay, somebody siya. The question goes like this. Estimate the enthalpy of combustion. Enthalpy of combustion. Oh, ganon. Combustion. Okay. And guys, what is this? Chemical Engineering Board Examination. What's this? 1991. Again from the Philippines. PRC, Licensure Examination for Chemical Engineers. Okay, of methane. Okay, like this. What's this? Using the average. Okay, average bond dissociation energies. Ganon. Bond dissociation energies. Okay? Ganon siya. Okay? And then nasa tables. Table lang siya. Kasama lang siya. Okay? So we have table. Ganon. So first is carbon to hydrogen band, single band. We have 400, what's this guys? 413 kilojoules per mole. Okay. And then we have oxygen to oxygen band, double band. We have 495 kilojoules per mole. And we have also carbon double band oxygen, 745 kilojoules per mole. Okay, and then we have also what's this? Oxygen OH. Okay, hydroxyl group or hydroxide. So 467 kilojoules per mole. Now I tell you another issue. If there's no table like this, you don't have to force to use this. Okay, guys, mga kapatid.
The Bluetooth device is ready to pair.
Hello mga kapatid. Okay, my microphone is low bass and I have to continue. Ako mag-charge ako mga kapatid because during the sound, the audio will be not good if I have no intensification. Intensification talaga. Intensification of my voice. Charge. Okay? Okay, so guys, okay, if there's no table like this, don't force. Okay, like that. So you will know that also in the atmosphere, or you feel the problem really in the first place. Okay, so take note always like this only, huh? Okay, but if no like this, only the kilojoules per mole, then use the regular enthalpy change of reaction. We have also regular. And the regular enthalpy change of reaction of the formation is different because the change of the products, the enthalpy change of the formation of the products minus the enthalpy change of the formation of the reactants, reverse siya talaga guys. Okay, nakakaloka, di ba? Okay, so we need to, remember. Okay, something like that. Okay, now, combustion, see, combustion of methane lang ginagihatan niligayon na. So we need to say, we know already what's the combustion process. So combustion process are all exothermic reaction. It releases heat energy to the surrounding coming from the system. Okay, so meaning to say negative delta H negative gives free energy, meaning to say spontaneous reaction, irreversible reaction. You get the point? Meaning it will never go back to its natural form. Okay? Like that. Okay, so CH4 methane, natural gas, okay, plus, okay, rapid oxidation is equals to carbon dioxide, greenhouse gas, okay, plus the water. So balance the chemical reaction. So, as I can remember, guys, the enthalpy change of reaction, delta H of this reaction, okay, negative 890.4 kilojoules per mole. Because I memorized this methane. Okay, so, see, it's not the same here in the table. Right? Get the point. Okay, so meaning to say this is another topic really. Okay, now we have to balance first. Carbon balance, oxygen 2, hydrogen 2, or 4 hydrogen, 2, 4, then ganon, like that. You get the point? Ganon. Okay, guys? So, we need to proceed now. Okay. Now, we have 1 mole of methane, 2 mole of oxygen gas, 1 mole of carbon dioxide, plus 2 mole of H2O. Okay, how can we do that? Okay, so bonding, chemical bonding of CH4. First, go to the methane. You should do this individually, mga palangga, ha? Okay, do this individually. For CH4, draw the Lewis dot structures of chemical bonding. Our parent element for the chemical bonding is carbon. So carbon has 4 electrons in the outermost shell. 10, 4 carbon. Ganon. So there are 4 hydrogen. Okay? So share the hydrogen into the 4 electrons. Okay? It's gonna be hydrogen here, hydrogen here, hydrogen here. So then connect the dot. And spread that one. Okay? So it's gonna be like this. Carbon. Okay, hydrogen. So completely shared the electrons of carbon to hydrogen. Okay, like this, completely shared ang carbon atoms to hydrogen. So this is non-polar covalent bond. There's no excess. Okay, electrons remain in the outermost shell. Meaning to say, no excess electrons, no lone pair. Okay? So non-polar covalent bond. So we will count how many single bond for this. Because in the average bond association, we will focus on the type of bond. So single bond, you have to count how many, like that. Okay, so single bond, 1, 2, 3, 4. In CH4, we have 4 single bond. Then times how many moles of CH4 in the chemical reaction? Only 1. So 4 times 1 ganon, is equals to 4. This is the technique. Okay. Now, oxygen gas. The parent element is oxygen because there's no another element bonded. It's going to be 2 oxygen. Ganon. How many electrons in the outermost shell of oxygen? 6. Right? So we get 1, 2, 3, 4, 5, 6. And this is double band. Ganon. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there are 4 excess electrons in another oxygen in the other side, and there are 4 electrons in the other oxygen side unpaired. So there are a total of unpaired 4 electrons unpaired. We have to count how many bonds. There are only one double bond. So 1. And then go to the chemical reaction. There are 2 moles of oxygen. So 1 times 2 is equals to 2. It's gonna be like that, huh? Always. Okay. And now we go to the carbon dioxide. Okay, carbon dioxide is equals to the parent element is carbon with 4 electrons in the outermost shell. Okay, 1, 2, 3, 4. We have 2 oxygen. Tadadat, ganon. Tadadat, ganon. So there must be 2 double band. Because you must complete all the electrons to be distributed all for oxygen, because oxygen has so many higher electrons in the valence outermost electrons or the valence electrons. So of course, the carbon will give it all to oxygen. So no more. So the carbon will be, electrons will be completely shared all, but there's remaining for the oxygen 1, 2, 3, 4. 1, 2, 3, 4. Like this. Oh, the same thing. 8 also, right? 1, 2, 8. The same with this one. So how many double bond now? 1, 2. Okay. 2. And a chemical reaction, how many moles of carbon dioxide? Times 1 is equals to 2. Ganon. And now we go to the water. Okay, water. So water is doing the another type of bonding, which is an ionic bonding. Okay, what do you mean by ionic bonding? Tempa muna sa akin. It's not really an ionic bond. It's hydrogen to hydrogen bond. Okay, not ionic. Hydrogen to hydrogen bond because this is not an electrolyte. Okay, like that. So this is hydrogen to hydrogen bonding or dipole to dipole bonding, meaning there are two poles. That's why di. Because there are two hydrogen outlet for the oxygen to be shared, something like that. Okay, so we have H2O. So our parent is gonna be oxygen. Okay, ganon. Two hydrogen here. Ganon. So there are 4 unpaired electrons of oxygen. Oh, ganon. So how many single band here for the hydrogen in the water? So there are 2. So 1, 2. So 2. How many moles of water? 2. So 2 times 2 is equals to 4. So the technique is count how many bands, whether single band, double band, triple band, times the coefficient in the chemical reaction, which is the balanced number of moles in each side, and draw the electron dot structures. This is gonna the thing of this average band dissociation energies, because we can use this later on in our enthalpy change of combustion reaction. This 1, 2, 3, ganun. So enthalpy change of combustion, delta H, reaction of combustion, delta change of combustion in the reaction. Okay, Rxn is equals to the summation of the enthalpy change of the combustion of the reactant minus the summation of the enthalpy change of the combustion of the product. Okay, ganon. Whole thing, close parenthesis. So we have how many reactants? We have the methane and the oxygen. So methane, ito na nakuha ganina mga 4. 4. Okay, 4 times the enthalpy change of the combustion in the reaction in the first and the methane. We have 413 times 413. Okay, ganon. Plus, because there are 2 reactants, oxygen. Ganon. Asa ko ito complete sa oxygen? Dara, 2. So 2. 2 times 2. Ganon, di ba guys? Kinaman tayo oxygen nga 2, so we have 2 na. Ato na din siya times ito. Kani siya, total na ni siya guys. We don't have to repeat. This 4, 2, 2, 4 are total already. So we need to rewrite only in this equation. Sorry. So 2. Okay, ganon. 2 times the oxygen gas enthalpy change of combustion, which is 495. 495. Then, close and open parenthesis. Minus a product do hapon. 2. We have carbon dioxide, but in carbon dioxide we have now 2. So 2 times carbon and oxygen man siya band. Okay, so 745. 745 plus water or hydrogen and oxygen band. And so in here, there's no water here, but it's the oxygen and hydrogen bond, elemental bonding. Okay? The elemental bonding will be specified, not the compound. Okay, here is in water, we have only the hydrogen and oxygen. So we will say oxygen and hydrogen bond. So we have 467 that we obtained already from the water, which is equal to 4, right? Mga palangga. So we have this 4 times the band of OH, which is 467, and calculate that one. Okay? Like that. Get the point, mga palangga. Okay, so 2 times 495 is equals to, nakakaloka, 2 times 495 is equals to 990. Ganon. 990. Okay, and then the other one, 4 times 413 is equals to 1652, mga palangga. So, i-plus mo siya, plus 990 is equals to 2642. 2642 siya kanan, diri sa reactant. Minus, ang sa product, mga palangga. Okay. 4 times 467 is equals to 1868. Then 2 times 745 is equals to 4090. Add, plus 1868 is equals to 3358. It's gonna be 2642 minus 3358. 2642 minus 3358 is equals to negative 716. So this is negative 716 is our enthalpy. Kilojoules per mole is our enthalpy of combustion of the chemical reaction of methane gas plus 2 moles of oxygen gas is equal to carbon dioxide gas plus 2 moles of water. So 716. Okay, it needs 716 of heat energy per mole to obtain this kind of reaction in your process. It needs this particular heat. So meaning to say, this will not produce a product like this if you will never have this 716 kilojoules per mole. Okay? Meaning to say, it is not a magic. It will just produce a product like this if you have a heat energy which is negative 716 kilojoules per mole based on our computation, and that is exothermic reaction, spontaneous reaction, and irreversible chemical reaction. Okay? Get the points? It's gonna be like that. When you see chemical reactions, you need to extract what types of reaction is that. So first, go to the 5 types of chemical reaction. Second, based on the processes, could be exothermic, endothermic. And then third, based on the spontaneity of the process, spontaneous, non-spontaneous. Or the last will be based on the how reversible or irreversible. The reversibility of your reaction. So four modes. If you know the 4 modes of chemical reactions, then perfect. You have high scores in physical and chemical principles subject in your day 2 of your chemical engineering board examination. Okay? Ganon. Okay, thank you so much. If you like this video, if you comment, then you can also comment if you want, and then you can share also to anybody else. Okay, the special topics of enthalpy of combustion and enthalpy of formation through average band dissociation energies and chemical bonding. Okay, thank you so much, mga palangga. You can subscribe to my channel, and I will be happy to do that also. And then you can click the notification bell for some latest episode. I am a singer, eternal voice. Oh, I'm finished. I'm done. Thank you so much. Bye-bye. God bless. But I still have one. We go back to the simplest enthalpy of reaction. I go to the complex first, and then now last simplest. But I have to stop this video. I will go to segment number 3. Oh my gosh! Diba? Nakakaloka.